Nowadays, we have many perfect digital kits options for STEM education. However, the approach to develop and implement integrated STEM education remains unclear. Across Australia, integrated STEM education is strongly advocated within both national and state curriculum. So, what is integrated STEM education and why it's so important? This term means the science of teaching across two or more STEM-related subjects to address and solve authentic problems through design solutions. It has three characteristics, including transdisciplinary integration, authentic context, and design problem-solving process. Integrated STEM education can bring positive improvements in student interest, engagement, career readiness, and critical thinking and problem-solving skills. Therefore, it will promote a country's sustainable development and economic growth. Although ACRA has suggested instructional processes for developing integrated STEM programs, it's not evident to teachers how they might use them and how the program connected with syllabus requirements. Recently, more and more researchers and teachers attempt using design as an overarching pedagogical framework. This idea may make sense because design indeed can address the three integrated STEM characteristics. For example, in this design of an office chair, the connected principles contain mechanical calculation and manufacturing technologies. What's more, the cup holder design represents a typical authentic solution. Design process takes a leading role to determine the promise of design-based pedagogy. Here are two design process models, engineering design cycle and design thinking process, which have been broadly adopted in STEM education. Unfortunately, they are both unable to fully address the three characteristics of integrated STEM education. So what is an inappropriate process model of design-based integrated STEM pedagogy, and how to use it to develop integrated STEM programs? Based on a collaboration with QUT STEM for schools, I ran this online teacher PD regarding design-led integrated STEM pedagogy in May of 2020. 23 Queensland secondary school teachers from 15 schools attended this workshop. I successfully empowered the 5 teacher groups to develop integrated STEM programs. The secret of success is the use of solution-based design process. This process model originates from the area of biomimetic design. From this case, we can see the birth as a solution brings working principle, and the designer converts the knowledge into the vector strap to solve authentic problems. Namely, solution-based design process can reconcile fixed content knowledge and the flexible process of authentic problem finding and solving. It consists of 9 steps. Step 1 to 3 represent a procedure of clarifying knowledge principles. Either a natural creature or artificial product can serve as a solution, while steps 4 to 6 are for identifying a problem. Steps 7 to 9 grant knowledge in solving the problem. I warmly welcome you to attend this PD if you are Queensland school teachers who have teaching experience in Year 9 or 10 STEM-related subject areas. Workshop 1 represents a design immersion. You will work through the 9 steps and understand how the principles of a parking sensor are converted into a design solution that protects children's eyesight. You will also be equipped with necessary design skills and mindsets. In Workshop 2, I will facilitate you to construct integrated STEM tasks. You have a chance to refine subtask description in the context of STEM education. More important, you will address the curriculum content targeted by the selected solution. Here is an example of one teacher group. Teachers outline the exact part of the curriculum content embedded in each step. Besides, you will also consider related achievement standards, which will assist in evaluating the quality of students' learning. Workshop 3 is for formulating implementation approaches of integrated STEM tasks. You will extend the corresponding procedural knowledge to key teaching and learning experiences. Here are displayed a number of step procedures. These procedures will help ground your teaching strategies and skills in the context of STEM education. For example, Step 1 contains 4 specific procedures. Next, you will use specific design skills and mindsets extracted from each procedure for sub-task implementation. Based on the outcomes of Workshop 2 and 3, the last workshop is for building a detailed unit plan for the classroom. You will use a special instructional model that contains these 4 components. Here is an example unit plan created by one teacher group. You can see the detailed information as blueprints about each step's learning task, supportive information, procedural information, and part-task practice. The teachers who attend the PD would like to recommend you attending these workshops because they successfully combine your existing teaching experience and skills to address genuine integrated STEM education. You will also be invited to group discussion and complete an individual survey at the conclusion of the sessions to evaluate this program. Incentives of $100 per person is available. For further information, please feel free to contact me by email and phone. Thank you so much, and I look forward to seeing you in PD workshops.